Let's talk about vapor pressure and what it does to a fluid system. So the first thing is, let's pull up something from our Physics 3 class. This should look familiar. This is our phase diagram for water, showing the solid, liquid, and gaseous phase of water. So vapor pressure. Vapor pressure is the pressure at which a liquid boils and is in equilibrium with its own vapor. If you've taken thermodynamics, this would be the saturation pressure. What we're concerned with is this line here between the triple point and the critical point. So along this line is the vapor pressure that we're looking for. When a liquid falls below this vapor pressure, what happens is it can change to a gas. So if the pressure drop was due to temperature effects alone, this is a process we would call boiling. If the pressure drop is due to fluid velocity, the process is called cavitation. Now, cavitation is bad because what happens now is you get these little bubbles that appear in your fluid flow. And they exist for a while, but eventually the pressure on the outside of the bubble causes the bubble to collapse. The surface tension can't hold the gas inside on its own anymore. And then what happens is when that bubble collapses, so if we have a bubble here, water rushes into the bubble to fill the void. And this is the process called cavitation. And it's bad because what happens when that water comes in to fill the void, we get an effect which is known as water hammering. And so it's basically that water just comes in and starts smacking against the device. Typically a ship propeller or a pump impeller. And this localized water hammering effect will eventually degrade the device. In fact, if we take a look at this picture from the book, you can see that this is a propeller that has undergone cavitation. You can see all through here, it's all pitted, and in fact here you can even see breaks in the propeller. So we do want to avoid cavitation, and that'll become even more important when we talk about pumps later on. But the thing to remember then is, how do we avoid cavitation? And it's pretty simple. So we look up the vapor pressure, and we compare that to our system pressure. As long as our system pressure is greater than our vapor pressure, it will not cavitate. Now, what happens if the system pressure drops below the vapor pressure? That is when we get the little bubbles that start to appear, and we can have that water hammering effect. And so, especially when we talk about pumps, we'll talk a lot about how to avoid cavitation. Now, there is going to be a neat little Nat Geo video that I've got here that kind of gives a graphical showing of cavitation with submarine blades. It's a pretty cool little video that'll help explain it, and then we'll have some problems in here before we move on.